Okay, so this is just the property on inverse variation. So inverse variation is a relation that can be modeled by the equation y equals k over x, or xy equals k, where k is the constant of variation. There's many different applications of variation problems, but in typical, the general idea is that if one variable is increasing, then the other one is decreasing. So if there's an increase in the y values, there's a decrease in the x value to balance out. Okay, in this example, I'm going to go and determine if each of the tables represent inverse variation or not. So you can use either formula to do this. The easier formula in this situation usually is the xy equals k formula for inverse variation. If this is indeed inverse variation, then when I calculate k, it will be the same for all of the sets of ordered pairs. So if I look at the first set of data, my x is 1 and my y is 12. So 1 times 12 will be my value for k. And 1 times 12 is 12. So that means the rest of the ordered pairs should also give me a value for k of 12. So going through with the second order pair, my x value is 2, my y value is 6, and if we multiply them, 2 times 6 is indeed 12. So the second order pair has the same value for k. I'll do the third one as well. So 3 times 4 will be k, which means k is still 12, so we're good there. And if I continue down the table, just not writing the last couple out, 4 times 3 is still 12, 6 times 2 is still 12, and 12 times 1 is still 12. So the value for k was the same for every set of points on this table. That means this is inverse variation. There are other approaches to doing this, but since we have this equation, that's probably the easiest if we're using that equation. We do the second example here. Doing the same thing using xy equals k. So we'll just multiply our x and y values. So 1 times 20. If we multiply them, that means k is going to be 20. If we check the next point, it's 2 and 17. So 2 times 17, x times y equals k. 2 times 17 is 34. Notice this time the values for k are not the same. And because k is not constant, like the constant variation suggests, this is not actually variation. Specifically not inverse variation. And there we go. In the next example, it says in inverse variation, we have x is 10 when y is 3. Write the equation to represent inverse variation, and then find the value of y when x is negative 6. Now, when it says inverse variation, that means the general equation is either x, y equals k, or y equals k over x as a general equation. I'm just going to stick with using this one. So as I go through and use this, typically these problems will have a complete set of information. So in this case, a complete set of information would consist of having both x and y. So here is our completed set of information. It is the x and y that goes together. So I know x is 10 and y is 3, so I'm going to plug those in for my x and y value. K is what we need to find first. So k is 30. Now, there may be more than one way to go about doing these problems. I like to use this strategy because it works for all the different types of variations and the combined variations that you might encounter. And the way you go about it is first finding k. Then once you have k, use it to write the equation, which is one of the things that we're asked to do. So the equation would be x, y equals 30. Or we could use y equals 30 over x. When you write the equation, you just replace k with its actual value. Now that we know k, the equation will be true for the rest of this situation that's going on. But usually, this would be the second thing you could be asked for in a variation question. And the third thing that you might be asked for is to actually use this equation after writing it, which is what we're actually asked here. Find the value of y when x is negative 6. So we can use either version of this equation. I'm going to stick with this one. I find that when you're solving for a variable, people tend to make more mistakes with that one. So I'm going to focus on this one because it's a little easier to use and a little bit less when it comes to making mistakes that I've seen. So I'm going to replace x with negative 6. Y is going to come back down. 30 is going to come down. We're looking for y, so y is left as y. We need to figure out what y is, so we will divide both sides by negative 6. Giving us y equals negative 5. And the last thing that we are usually asked for is this last part right here. So a lot of variations questions will ask you for one of three things. Either the value of the constant of variation, the equation, or to use the equation. And all three were actually done here. It's just about where you stop at. Okay, in this example, we have the weight needed to balance a lever varies inversely with the distance from the fulcrum to the weight. Where should Willis, who weighs 150 pounds, sit to balance the lever with Frankie, who weighs 120 pounds and is sitting 6 feet from the fulcrum? So first of all, if you don't know what it's talking about, it's essentially talking about a seesaw, the fulcrum being the balancing point, and one of them is sitting 6 feet from the fulcrum. We're looking how far Willis should be sitting to balance out with Frankie. So, variation problems, whenever it's applications, and this goes for everyday life things too, but whenever it's a word problem format, it will typically tell you right away what the variables are. And when it comes to word problems, I like to use variables that make sense in the situation. So we have the weight needed to balance a lever. So instead of x, y equals k, I'm going to turn this into w for weight. And since it says inversely, that's how I know to use this x, y equals k format. But instead of x and y, I'm going to use w and, well, the other variable would be dealing with distance from the fulcrum to the weight. So since it's distance, I'm going to use d. And then k is the constant of variation, and in variation problems, k is just going to be k. So here we have a modified equation, which makes it a little easier to figure out where to plug stuff in. Now, the first phase of the problem is usually to find k. In order to find k, we need a complete set of information, so both a weight and a distance that goes together. In this case, that's talking about Frankie here, who weighs 120 pounds and is sitting 6 feet from the fulcrum. So his weight is 120 pounds. His distance is 6 feet. which means if I multiply that, that is 720 equals k. Now that I have the constant of variation, which is the first phase, second phase is to write the equation. W times D equals 720. You can also use the other form of the equation as well. Either way would work. The final phase is to actually answer the question. So our actual question is asking, where should Willis, who weighs 150 pounds, sit? So we are given the weight for Willis. We're looking for the distance here. So the weight is 150 pounds. His distance is what we're looking for, so we'll stay D equals 720. And then to get the distance by itself, we'll divide by 150 on both sides, which gives us 4.8 for D. And because this is a word problem, since distance is represented in feet, as indicated by this little portion right here, it would be 4.8 feet from the fulcrum.